Women today have the power to become a doctor, a lawyer, or even a police officer as easily as every other human being does it. Well, not easy, but you know what I mean. Although the way of women around the 1900s was especially tough, since they were paid less and didn't get many opportunities the same way that men would. Although for some women, they pulled through the timeline and contributed to many discoveries and innovations today. I'm your host, Sam, and today we're going to talk about the women who altered the history of ocean science. Marie Tharp is one of these women, by dedicating her research to mapping the ocean floor and creating a statement. Who is she, you may ask? Let's debrief. Born on July 30th, 1920, Marie Tharp was born in Ypsilanti, Michigan, by her two loving parents, William Edgar Tharp and Bertha Tharp. Her father worked for the United States Department of Agriculture, and her mother was a schoolteacher. William's job consisted of him working as a surveyor, researching and charting areas to collect soil samples and rocks. Marie often helped him with his tasks, so this opened the door for early introduction to map making. Because of her father's work, this required the family to move around often, which led Marie to attend about 17 different schools before she graduated high school a few years later. After graduating, she took a year off to help out with the farm after her mother's death in 1936. In 1939, just 3 years later, Marie began studying at the University of Ohio, where she studied a music major and graduated with a music and English degree. After she graduated, she had a rare chance to be a part of an accelerated geology degree program in Michigan. During her education, she earned her master's degree in geology in 1944 and master's in mathematics in 1948. Since working wasn't a solid option for Tharp in the late 1940s, she took a job at an oil company, except she found the confinement of being in an office unfit for her, since she collected maps and data for the men going into the field. She moved to New York City and found drafting work as one of the first women at the Lamont Geological Observatory. She became a research assistant at Lamont and Columbia University, where she met Bruce Heezen, a current geology graduate student whom she'd be working with for the next 30 years. This is where Tharp begins her private research project.
Yeah, my name is Larry Mayer. I'm the director of something called the Center for Coastal and Ocean Mapping at the University of New Hampshire, and that's a national center focused on mapping both the seafloor and the water column using all different techniques to figure out what's there.
Bruce Heezen would go out on research vessels, collecting the initial data, much of which the raw data came from sonar measurements of the ocean depths. This data then would be sent back to Marie, and she'd use the readings to draw the details of the ocean floor using longitude degree by latitude degree, only drawing with pens and rulers. As you can imagine, this process was very lengthy and technical, but Marie was certain to get the task done. She relied on instinct for a lot of her map making, yet her maps are remarkably accurate. To make her historic maps, Tharp relied on depth data collected by research cruises. But since the ships couldn't cover every inch of the oceans, it was up to Tharp to fill in the blanks in between those lines, to try to understand how all those pieces fit together. For this, she had to rely on her intuition and knowledge of geology, to the point that Heezen once wrote that, "What people think the bottom of the ocean looks like, that is, what most scientists and informed laymen think it looks like, is what Marie Tharp thinks it looks like." Fortunately, she turned out to be right. Her maps are surprisingly accurate.
Recently, it's really providing a much more complete picture of what the ocean floor looks like. And also work we do in Greenland that is trying to understand what might be causing rapid sea level rise and rapid melting of ice in Greenland. And that's related to what's going on the seafloor. So that's one of the most recent results.
I am Jackie Dixon, and I am a professor at the University of South Florida. I am an igneous petrologist, geochemist, and former dean. So I focus my work on the study of submarine volcanoes. So I use volcanoes to tell more about what the interior of the Earth is made of, and particularly water and carbon dioxide, and how that gets transferred from the deep Earth into the atmosphere. As a high school student, I was really into gymnastics. I was on a private club team, and that was my life, and that's what I was going to do. I got injured in my junior year, and instead of going to Switzerland with the team, I ended up going to a summer school class in chemistry, and just always did well in science and math. And then I went to Stanford as an undergrad and was a chemistry major, and was very unhappy as a chemistry major because everyone else was a pre-med and I didn't want to be a pre-med. And I took an oceanography class. And with that oceanography class, I learned that the middle of the ocean was active volcanoes and that the oceans were splitting apart. And so this was in the late 70s. And so plate tectonics was it gained acceptance, but it was still new. That was just it. I was so excited by that. And that's been the rest of my career.
The first map published of the North Atlantic Ocean was in 1957. The map's drawings showed that the ocean floor was not flat, but covered with features like canyons, ridges, and mountains like on land. She made 2 additional maps, one showing the South Atlantic Ocean floor, published in 1961, the other one showing the Indian Ocean floor in 1964. These discoveries were brought to the attention of many other scientists, but they dismissed Tharp's theories as girl talk. Now let's deep dive into some basic historic facts about our past. More specifically, around the 1920s up into the 1970s. She believed she'd become a teacher, like her mother. She began her career at the time when few women became scientists. Because of her gender, she wasn't even allowed on the ships that collected the seafloor data that she used to make her maps. She didn't even set foot on a research cruise until 1968. Women were not recognized by some professional societies and had long been discouraged from working in the field. Tharp's mentors knew it'd be an uphill battle. One encouraged her to work on her drafting skills to increase her chances of getting any kind of job in the earth sciences after the war ended. Now, as for Marie's girl talk, the concept of continental drift, or seafloor spreading, the idea that continents move by spreading across the ocean bed, was a very preposterous theory to make without solid evidence. At the same time, there was no way to prove that a massive supercontinent had ever existed, or that the continents could move through the ocean floor by themselves. Besides, subsurface geology, the study of rock and soil beneath Earth's surface, didn't really exist yet, nor did scientists have ways to map the ocean floor, which they assumed was drab and flat.
The past 15 years, as an administrator, I was dealing with Deepwater Horizon oil spill, sea level rise, climate change, fish populations, barcoding DNA. So now I've returned to the faculty. I have a proposal in to get a new instrument. This is called the Fourier Transform Infrared Spectrometer. That's how I measure the concentration of water and carbon dioxide in magmatic glasses. So when lava erupts underneath water or under ice, it quenches quickly and it forms a glassy rind. And that glassy rind preserves some of the water and carbon dioxide, but if it erupted on land, it would just go up into the air. And so I've got a proposal in to get a new instrument that does lots of new things. We understand volcanoes pretty well that erupt from hot spots like Hawaii and Iceland and the Galapagos. But there are a lot of other smaller volcanoes on the seafloor that we don't fully understand how they form.
Tharp continued on her work, and eventually her research more confidently proved the Rift Valley theory. She tried to show her findings to other scientists, and even Heezen, but they were continually rejected. Although when she showed her evidence to Heezen again, he became convinced that she was correct. He only changed his mind when evidence of earthquakes beneath the Rift Valley she had found was discovered, and when it became clear that the rift extended up and down the entire Atlantic. Tharp proved the idea of continental drift, a huge accomplishment for the science community. It would still be several years before Tharp and Heezen's findings were fully accepted in the geological scientific community. In 1956, Heezen took credit for the discovery that Tharp made, and people were led to believe the discoveries and work that were conducted was Bruce Heezen's. Little did everyone know that the scientist had Marie on his side. After Heezen died in 1966, Tharp focused her energy on completing a comprehensive view of the world's ocean. Tharp eventually joined a data collection research expedition in 1968 and completed a full world ocean map in 1977. This map revealed a 40,000-mile-long underwater ridge that runs along the globe. After about 15 years of work behind the scenes, Tharp finally went on research cruises by herself, including trips to Africa, the Caribbean, Hawaii, Japan, New Zealand, and Australia. The discovery revolutionized our understanding of how nearly everything on the planet works.
Starting in the field of oceanography, it was unusual to be a woman. I was doing this in the 50s. And so it was very unusual for women to get a job at Lamont. I did work with scientists at Lamont as a part of my research. It's a really cool place. And plate tectonics was born there. And she had the vision and the creativity to pull the data together in an integrated way and visualize it in a way that is still used today. So, she was just at the frontier, not taken seriously as a woman, and she still got it done.
In 1996, she received an Outstanding Achievement Award for the Society of Women Geographers, and in 1997, the Library of Congress Phillips Society honored her as one of the 20th century's outstanding cartographers. In 1998, Tharp was honored during the 100th anniversary of the Library of Congress Geography and Map Division. Tharp died of cancer in 2006 at the age of 86, but her legacy lives on in the countless women scientists she has inspired.
Her imagination was actually quite accurate. And she also discovered, very carefully piecing this all together, that there was a ridge in the middle of the Atlantic Ocean. And on the top of that ridge was a little rift, a little valley. And she realized that these all connected up. And that became a very, very important part of the theory of plate tectonics, which revolutionized how we thought about how the Earth has come about. Because, I mean, she basically kind of pioneered this approach of taking bits and pieces of information and then trying to put them together into a collective view and a beautiful map, and using that map to understand scientific processes. It's a lot of my life is in that same sort of direction.
Today, we recognize our contribution to oceanic exploration. An international effort to map the entire ocean floor in detail by 2030 is underway, using multiple ships, led by the Nippon Foundation and the General Bathymetric Chart to the Oceans. Tharp once said, "I had a blank canvas to fill with extraordinary possibilities, a fascinating jigsaw puzzle to piece together. It was a once-in-a-lifetime, a once-in-the-history-of-the-world opportunity for anyone, but especially for a woman in the 1940s.
Well, we're actually, the maps she made back in the early 60s were maps of the imagination based on a little bit of data. What we're doing is collecting all the real data and showing how remarkable she was in her intuition, because a lot of the features that she imagined existed really do exist.
We have at the College of Marine Science, we have something called Oceanography Camp for Girls. If you look on the website, USF College of Marine Science and Outreach, you'll see the Oceanography Camp for Girls. It's been going on for 30 years, and it focuses on girls, rising 8th graders, at a time where girls tend to lose interest in science, and it focuses on underrepresented students. There are only like 30 students every summer, and it's a month long, and they do hands-on, and they go on field trip, and they interview women scientists. So it's a very hands-on, positive experience for these girls. Joining organizations or supporting organizations that are doing all they can to protect natural areas. And protecting the land is just as important as the ocean, because the more you develop the land, the more you're polluting the ocean.